Welcome to this week's lecture in CIT 230, Advanced Java Programming. Last week, we began by talking about the three pillars of object-oriented programming. Last week, we focused on encapsulation, where we hid the implementation of our class code from the person who would consume or create objects out of our class, and we enabled that in a good way by using Java.doc comments. We're going to continue today by focusing primarily on inheritance. We're going to expand upon what we started last week. We'll do a little bit of review in Java.comments because we will use them for the class we're creating today as well. And we'll do a full example that shows how inheritance works. Before we get to that example, I'd like to kind of define inheritance. Inheritance is the ability in the programming language to create classes that receive the properties and methods of another class, which we call that other class a superclass. How it works is, take for example, if we had a class called vehicle, where that could be anything from an airplane to a hang glider to a bicycle to a car. All of those vehicles may have properties such as speed and direction, which dictate the state of the vehicle. How quickly is it moving, and in what direction is it headed? And we may have methods like accelerate, decelerate, where we can play with or modify the speed property through those methods. And we may have something like a turn method that allows us to change the direction on that vehicle. We could then create a second class called motor vehicle. Through inheritance, which is indicated by this arrow here, the motor vehicle would receive or inherit the speed and direction properties along with the accelerate and turn methods, so we wouldn't have to code those. We wouldn't need to create those pieces of the functionality of the motor vehicle class because we would inherit that. One of the things that where this ties back into encapsulation is we also don't need to precisely know how the vehicle class was coded. We don't need to know how the accelerate, decelerate, turn, or other methods were actually written in order to have them inside the code for our motor vehicle class. We'll get lots of examples of this, particularly starting in the next lecture when we start looking at graphical interfaces, where we get a lot of very powerful methods and very powerful code that we just inherit from the superclass, so that we don't even have to know how those things are created in order to expand on them. And when we inherit, usually it's so that we can expand upon what's there. So a motor vehicle, that would include everything, say, from a bus or an RV down to like a motorcycle or a scooter, might have something like the number of wheels, the type of fuel it uses. Is it electric? Is it diesel? Is it gasoline? Those kinds of things. And we can continue what we call an inheritance chain, by further inheriting from classes that also inherit from something else. Again, that's something we'll see many examples of throughout the semester as we work with various objects and classes that we make objects from. We'll see lots of examples of very deep inheritance chains. But what's nice is in this particular example, the car class still has the speed, direction, accelerate, turn, and everything that came from vehicle, as well as the number of wheels, type of fuel, and everything that came from motor vehicles. We may have additional properties such as the number of doors, the make, the model, things like that go along with the car specifically that may not apply to vehicles in general or the motor vehicle. So now that we've kind of looked at that, let's think about doing an example. So if you remember from last week, from the last lecture, we did a person class. And I'm going to open that up for us just to review. The person.java had a first name, a last name, a middle name, a courtesy title, a suffix, a gender, and an age. And no matter what kind of person we're dealing with, these are things that are common, remembering that even if someone doesn't have a suffix, like many of us don't, we can leave that that suffix as null, like we did in this no argument constructor, or we could populate it with like a zero length string or an empty string to indicate that there really was no value there. So with that in mind, we may want for, say, as we said here, this generic person could be used for an application for human resources, or equally valuable in a video game type of setting. So let's say we were going to create a human resources program. So just as a review from last time with our java.comments, we might make a very basic employee class that inherits from or extends the basic person class that we previously built. Something like that. I put in here this or extends, as we'll see in a minute, because that's sort of that ties into with the way we do it specifically in Java. We'll still have our @author and our @version tags associated with this. And then we can build our class. Public class employee extends person. This new keyword that we probably haven't seen before, I'm going to go ahead and save this and call it employee.java so that we can see sort of the nice color coding that we saw last week inside of Notepad++ here. so that you can see that specifically extends is a keyword within the Java programming language that indicates that the class we are creating here will inherit from the class that it's extending. So what that means to us is that the employee will have a first name, a last name, a middle name, a courtesy title, a suffix, a gender, an age. It will have access to constructors to fill those properties in, and it will have set methods for every one of those properties, as well as the appropriate get methods that go with each of those properties. We get all of that automatically by extending the person class. Now, one of the things that I do a lot in this class is look at the API documentation, and as we looked at last week when we were talking about Java.comments, one of the reasons is it's good to become comfortable with the way this looks and the way this works, because we document our own classes in a similar way using Java.comments. Now, in the Java.lang package, which is the default package that we have access to when we're coding any Java program, one of the things that's in there is the object class. Now, one of the things that you may or may not have noticed when you were looking at the API documentation up to this point is underneath the name of the class, this refers to the inheritance chain of whatever it is we're coding. Object is a very special class definition in that it is the only class definition that does not inherit from another class. Object is called the root class, as you can see in this sort of description down here. When you don't when you don't extend a class explicitly like we're doing today, implicitly your class inherits from java.lang.object. What this means is that all classes we create, at the very least, get the properties and the methods that go along with the object class. And one of the things you'll notice when you do your Java.comments is there's this little box here that talks about methods inherited from class java.lang.object. We have a clone method, an equals method, a finalize method, a get class, hash code, notify, notify all, toString, and 3 versions of await using overloading in addition to whatever we have there. Now, what we're going to do today in our employee is employee will be 1 down and indented from person, which is 1 down and indented from object, which just means employee inherits from person, which inherits from object. So employee gets everything person has, which includes everything object has. In some programming languages, we can have multiple roots in our inheritance chain, meaning that a single class can inherit from multiple classes that do not have an inheritance relationship already. Java does not allow that. That's called multiple inheritance, and it's something that the designers of the Java language intentionally left out to remove certain aspects of complication from the language. And when we do start looking at something called interfaces in future lesson, you will see that we can implement interfaces while also extending classes, and that allows us to sort of simulate multiple inheritance. And one of the things is that for most programmers, they don't find that they miss multiple inheritance, and the benefits of not having it outweigh the limitations of not allowing it. If you didn't super completely follow the multiple inheritance discussion, just file it in the back of your brain in case that's something that, as you're developing as a Java programmer, you come to the point where you're thinking, boy, I'd love to extend two separate classes into a single class. Just remember, you can't do that in Java. But as I even said in the PowerPoint, we do inherit from everything along the inheritance chain. So look for more of that at a future time. So now that we've decided we're going to extend the person, what we want to do is add the things that are specific to an employee. For example, I might have an employee number property. This is like the individual identification number for a particular employee on the job. One of the things that comes primarily from data science and database types of parts of computer science is the concept of unique identifiers that we often call primary keys. These identifiers are better indicators of an individual's identity, better than, say, their name, because let's say your name was Robert Johnson. You can imagine there are a lot of people in the world named Robert Johnson, and if you were in a large organization, the likelihood that more than one Robert Johnson working in the same organization would not be an outrageous idea. So having something like an employee number that we can associate with all of the other things that makes each of the Robert Johnsons who and what they are is preferable. And you'll notice, that most organizations that you work for will have such a number, much like you have a student number, your NSHE ID or your student ID that you use here at the college, because in a school of more than 35,000 students, we have lots and lots of duplicate names. So keep that in mind. I think job titles and departments are fairly self-explanatory. Most organizations are going to have a title for each of their employees, and they'll be assigned to some branch or area of the business. And of course, we'll have a salary. Now, much like we did with the person, and much like we do frequently in all object-oriented programming, we frequently have a no-argument constructor that creates a generic employee. That gives us the ability to create an object before we know what we want the values for our specific properties to be, and we can use the sets and gets at a future point. In here, we're going to add the employee number, and we will make it 1 followed by 8 zeros. Kind of hinting at the fact that our employee numbers are going to be 9 digits, and they'll start with a non-zero integer. We'll talk more about that when we do some data protection a little bit lower in the application. We'll set the default job title as a trainee, kind of indicating, people generally come in at the bottom floor, but again, we might also hire someone in a different position, but just by default, we'll set it there. And by default, we'll set their department as human resources, since they're the ones who will be primarily using this application. If they have to, make objects that are generic, they'll want to keep track of those. And we'll make the default salary 0, because we want to, we don't know anything about the employee, so we'll just set it as 0. As a matter of personal style, you'll notice I always do my floating point numbers, doubles and floats, with even if they're integer, they have an equivalent integer, I'll generally put the 0.0 on the back of it. One of the things you most likely learned earlier, whether it was through a CIT 130 class or some other introductory lesson on Java, is that with pure integers like 3 divided by 2, even if we're assigning that to a double, 3 divided by 2 is 1, where 3.0 divided by 2.0 is 1.5. To prevent any issues like that, you'll notice that I'll always, even floating point numbers that have nothing past the decimal point, I'll put the 0.0 on the back, simply for the sake of not running into any issues. Now, here's one of the places that we gain some benefits from our inheritance. So we may have a constructor that takes in the most common values for any particular employee, which would most likely include their first and last name, their gender, and their age, and we'll go ahead and also take in their employee number. Now, through inheritance, we have access to the constructor on this side that takes in the first name, last name, gender, and age, so we can start or seed our object with a person by making reference to the superclass through a call like this that sends the 3 strings and byte over to the superclass's constructor that has that signature. This keyword super replaces the extended class name with the with the super so that it understands at this point we are calling the constructor for the class we've extended called person that's going to take in 3 strings followed by 1 byte. And it will even handle all of the data protection that we did over here by, protecting the values of gender and the value of age, where I don't have to check that over here. And in fact, it would be silly unless I wanted a more stringent restriction here. It would be silly for me to check those because it will check them on the other side in this constructor whether I check it or not. So it's a waste of my time and my effort to check that. And remember, even with encapsulation, if I don't have the ability to just flip over to this other tab and see what that data protection is, I have the API documentation that tells me that that constructor will throw an illegal argument exception if male, female, or unspecified is not the supplied gender, or if a negative age is supplied for the age. That's all done for us. So our instinct, because this call right here throws an exception, would be something like this, where we might think, oh, I need to do some kind of try and then catch illegal argument exception IAE, and then do, some kind of system.out.println thing here. But indeed, this is very atypical for us to do. Employee is a class that is not going to be run. It is going to be instantiated as objects within some other program. Now, presuming that that program will, at some level, whether something inherits from employee that is then used in an interface type of program, or directly done that way, it's better for us to allow the calling program to deal with this. It's considered bad practice to arbitrarily write to the console or even to do pop-ups out of a class definition. So what we do instead is what I call passing the buck. Now normally that has a negative connotation, but in this case it is the preferred behavior because it allows us to let the program creating the employee object to decide what to do if an exception is thrown. So what we do here is we add the keyword throws instead of throw like we do when we throw an illegal exception. Throws basically allows us to take any illegal argument exception that comes from the superclass and pass that to the caller of this constructor. So we will additionally check the data coming in on the employee number. So as I said before, we want to make it a 9-digit integer 1, 2, 3, 4, 5, 6, 7, 8, 9 that begins with a non-zero integer. So I'm going to make sure that employee number is at least 1 followed by 8 zeros, meaning that any number that is fewer than 9 digits, even if it has leading zeros, won't be valid here. And I don't want more than 9 digits. Whoops. So I need to make sure it's less than or equal to 9 nines. And what that does now is that guarantees that the employee number will have at least and no more than 9 digits. It will be exactly 9 digits, and none of those digits will, none of the leading digits will be a 0. This may sound or look familiar because this actually is the format that is currently used for student IDs or NSHE IDs throughout the entire Nevada system of higher education. And just as a programmer, if you're wondering why someone might select that, is if we have variable length numbers for our identifier, or allow leading zeros, it can be very difficult to do comparisons or to see data on various employees, and these are not, even though this is an integer, as it says up here, it's not, we're not going to add these together or subtract them because that doesn't do anything of value. So in many ways, we're dealing with them almost as strings, and for a unique identifier, it can be very, very valuable for them all to have the same length. So that's just sort of why that kind of scheme might be used. There are a lot of systems that don't do that just do sort of an auto increment and throw in the leading zeros. But as you get further and further into working with data, particularly data analytics, a lot of times it'll intermingle things that start with 1. So 1, 10,000, and 100 million all sort of sit together before 2. And we kind of don't want to get into that area. So what we're going to do here is if it meets that criteria, then we'll set the employee number equal to employee number. And here is a place where we will throw our own illegal argument exception. And since we're creating a new one, we'll set it with our own message, something along the lines of all employee numbers must be 7-digit numbers beginning with a non-zero integer. I said 7. I don't know why. 9-digit number beginning with a non-zero integer. Now, one of the things, just to kind of look more at how inheritance looks throughout the Java API, and also to get more familiar with the API documentation, and to give you a little more insight into exceptions that you may not have learned, some more under the hood type of stuff, let's go back to our java.lang library, and if we scroll down and we see exceptions, you'll see the illegal argument exception. Now, one of the things you'll notice here is there's a much deeper inheritance chain here. As always, that inheritance chain begins with java.lang.object. All exceptions will have java.lang.throwable in their path. All exceptions will have java.lang.exception in their path. Some exceptions we'll see have this runtime exception, and some will not have the runtime exception inside of in their inheritance chain. This is a determining factor in whether an exception is called checked or unchecked. Illegal access exception is checked. What that means is that as a checked exception, we must check for it. We must either put it in a try-catch block or pass the buck with the throws like we did in our own code here. The throws, it would be a throws illegal access exception, whereas an unchecked exception, one that says runtime or has runtime exception in its inheritance chain, does not have to be put in a try-catch block or passed on to the calling program to be handled. But that doesn't mean, just because something is unchecked, doesn't mean we don't want to check it. So let me give you just a little more depth here. What we know from the, actually let's go back to our own generated code. So when we see this, when we look at the description in any API or java.comments for a class, there should always be this throws area. If there's not, then that indicates that that method does not throw any exceptions, such as set first name. There's no data protection on set first name, set last name, set middle name, so none of those throw an exception. That means we absolutely don't care. There's going to be no needed try-catch block there. But when exceptions can be thrown, they need to be documented in this way so that the person consuming your class, either to extend it, as we are now, or if they're just creating objects with it, if they need to know whether to put that in a try or catch block, they can look what kind of exception is thrown and what are the conditions under which it is thrown. And what they may see is, well, it's thrown if the passed-in gender is not male, female, or unspecified. If this object, the person object, is created, say, from a user interface where the employment analyst at your human resources department is typing in the information about the new person, they may accidentally type in the wrong thing. They might type too fast and spell male with two L's or something else. and being able to, uh, being able to handle that, you're going to want to put that in the try and catch block inside your interface code, because that is a user style error. The reason they have checked and unchecked exceptions is typically the designer of the exception is anticipating that the exception will only be thrown in instances where the consumer of the class, coded incorrectly. For instance, if they were instantiating a person within the application not based on any input from the outside user, then that would bad data would only get in there if they coded it poorly. And in general, if it's only going to happen if the person coded it badly, you don't want to do tries and catches, because if you wrote the code badly, you want it to crash. If that's a little fuzzy right now, we'll talk about it maybe more as we go through the class, and also to be able to use exceptions, you don't really need to know that, but I like to supply sort of these under the hood extra pieces so that you really understand the way that Java's designed, and learn more about good programming practice. The key takeaway here is that when you're consuming anything from a class, whether it be a constructor or another method, reviewing the various exceptions that can be thrown and determining whether that could happen due to user error within your program is what you need to use as the indicator of whether it goes in a try or catch. And if it is a checked exception, you're going to have to do it anyway, because otherwise the compiler will tell you that you have to handle the exception. So if you get that with your compiler, at least now you also have a little bit of insight as to why that might occur. So now we have our two most common constructors here. I'm going to go ahead and borrow my Java comment here in the interest of time and consistency. Since I'm consuming the superclass, I still have 4 of the same parameters with just one addition. That's my @param no, the the unique employee number of the new employee object emp number must be a 9-digit integer that begins with a non-zero integer. And we want to be careful with our cut and paste. Remember, I'm building employees here, which, while employees are also people, it's more specific. We don't want to throw off people with our comments, so we will want to replace those words. And this is one of the things that I really want to point out. In general, we want to be careful with our Java.comments. I know that particularly among beginning programmers, early programmers, comments feel like an onerous task, or like the teacher is like we're torturing you by making you comment, so you just want to throw in the fluff. It doesn't break the compilation anyway. I just like to watch code work and do amazing things. But remember, the Java.comments are going to be looked at by someone other than you. You want these to be very clear. When we do the second homework assignment, we will be using classes that were created by other students that you may or may not ever meet. And you're going to want their Java.comments to be very clear, and they're going to want your Java.comments to be very clear. So don't rush through this in a way just to get things done and turned in. Try to be very careful with the comments so that it's very clear what it is it does. In this case, there is a third condition that can cause the illegal argument exception, and so we could say, or if the passed in employee number is not a 9-digit integer that begins with a non-zero integer. Again, being very clear what it is that causes the exception. So that does that. In the uploaded version of this, which is going up shortly, there will be an all. There will be a constructor that takes in all the possible inputs, but in the sake of time and to keep the flow good, we're not going to build that live. That'll just be available in the complete example that you can download and look at yourself. So what we are going to do is we'll look at a couple of set methods. So as you might imagine, we'll have a public void set employee number that will take in an int no, and it is going to do the same data check. So I can copy that and put it down here. And for the Java.comment, we might say something like a set method to change the value of this employee object's employee number. And I mentioned last week, one of the things we like is consistency in our Java.comments. So if we describe the same parameter in more than one method, it's good to copy and paste because we're much less likely to make typos or be inconsistent. This is going to have an @throws illegal argument exception, and this will be thrown if the passed in employee number is not a 9-digit integer that begins with a non-zero integer. We might also have a public set job title. That's going to take in, oh, I forgot the void. It's not a constructor, so it needs an output type, even if that output type is void or nothing. And that's going to take in a string called title. Oh, I'm stuck inside my comments still. Again, my clue was things not turning the nice colors that indicate keywords and things like that. I forgot to close out my Java comment above. So in this case, it may be something like this, where we are going to check, say, if title dot equals director or title dot equals manager or title dot equals analyst or title dot equals trainee, something like that. You can make, obviously, in a real human resources application, we may have a very long list. For the sake of a simple example, I'm just going to keep it limited so that we can set the job title equal to title or throw our illegal argument exception. Now, I know at this point, especially this being the second lecture, this may feel a bit repetitive, but in general, it's good for things to feel a little repetitive. In the sense that that means you're really comprehending it. You'll notice in a lot of my projects, you do sort of the same operation more than once. The point of that is to get it to sink in. When you see something and it just makes sense and you move on, you're not really committing it to memory. So it's good to see it. It's good to then see it again. And then it's good to do it and then do it again. So while it may feel slow right now, believe me, as the class pours on, you'll finish this semester and you'll have seen, many, many, many concepts that you have not yet seen and that are going to really give you a lot of tools and things to use in your own code development. So here the illegal argument exception may be something like or actually I'm going to say valid values for job title are director, manager, analyst, and trainee. And that will be that. Again, the full example that I upload will have a full set of all four set methods. In this live example, I'm not going to go that far. I'm just only going to do the two. But note that the value of this employee object's job title instead of employee number, and this will be title, the job title of this employee object. Valid values are director, manager, analyst, and trainee. Another solid point in your Java.comments, when you talk about these valid values, remember to be case sensitive. Here it's checking for an exact match on the string director with a capital D, manager with a capital M, analyst with a capital A. If we get sloppy in our Java.comments and we say trainee with a lowercase t, the consumer is going to think trainee with a lowercase t, and when that doesn't work, when that throws an exception because you used capital T down here, then you look sloppy. Especially if they test it and realize, oh, it works with capital T trainee, but their Java.comment said lowercase. It just doesn't look good. So just be, again, careful, consistent, and clear in your Java.comments. So this is thrown if the passed in job title is not one of director, manager, analyst, or trainee. Again, here that may feel like I'm writing the same things there. Again, it may be a little repetitive, but this is reality. These are the things you have to do to make your code really good, really usable, really shareable. These are the things that these are the practices you want to get good at now, because it really is something that makes you a better developer. So we will have all of our get methods just like we would on any other object. And as you'll see, those aren't getting any more complicated, even though we're now in an advanced class. Some things, like get methods, don't really get more complex with more programming. Here, really, all we're doing is sending back the values of these particular properties. So, we're just sharing the value, and so that's not rocket science. It's just a simple return. There's not much to it. They'll look just as you expect them to look. And but we will still need Java.comments that will say a get method that returns the current value of this employee objects employee number. And likewise for our other gets. So this primarily covers sort of the most basic example of inheritance. The first homework, which has already been posted, allows you to create your own class, whatever your imagination can dream up other than employee, to extend the person class. One of the things that can be fun in a advanced class is having a certain amount of autonomy to create something with a little creativity. Not, where every single person's thing that gets turned in looks exactly like every other person's thing that gets turned in. It makes it more interesting for you as a programmer. So, now as an advanced student, I want you to be able to explore that creativity a little more. So this example will be posted shortly, and you will have that at your disposal to look at as you work on that first homework. I look forward to our next lecture, and take care.